So in this lesson, we're going to be talking about solving and checking one-step equations. We're going to deal specifically with one addition problem and one subtraction problem. We'll take some notes, then we'll write our first equation, we'll solve it, and then we'll check it. So what exactly do we do in order to solve a one-step equation? Well, the goal is actually pretty straightforward. It's pretty simple. The goal is always to do this thing called isolate the variable. Isolate the variable. And all that means, that word isolate means to get by itself. So basically what this means is we're just going to get the variable alone. Isolate the variable. In parentheses, I'll put get alone. So in other words, you're going to have the variable, whatever the variable is. It might be A, it might be X, it might be Y. Remember, a variable is just a single letter by itself. You'll have that variable alone. So how exactly do we isolate the variable? We have to use these things called inverse operations. Let's write that down. Inverse operations. Now, in mathematics, there are 4 key operations, and the operations are addition, subtraction, multiplication, and division. Those are the 4 key operations. And this word here, inverse, just means the opposite. So what we're saying is we use the inverse or opposite, inverse or opposite operation. Let's put opposite, not operation. So the opposite operation. So for example, if I have the operation of, well, that is ugly. Let's try that again. Let's just put opposite here. Here we go, opposite, the opposite operation. So for example, if I have addition in my equation, then I'm going to isolate the variable by using subtraction. If I have subtraction, I'm going to use addition to solve it. If I have multiplication, I'm going to cancel it out with division. And if I have division, I'll cancel that out with multiplication. Now, the important thing is, and this separates equations from expressions, equations have an answer called a solution. So make sure you have this. A solution is the only value for the variable that we find that will make a true statement. And it has the following format. So it's going to be a variable equals some value, because the variable is going to be by itself and it's going to be set equal to some numeric value. For example, you could say something like x equals 2. This is the format for a solution, because this is saying, hey, the only value that will make the statement true, the equation true, is when this value x equals 2. Okay, so our goal is to isolate the variable using inverse operations to get a solution. Now knowing that, let's try our first equation. So let's say we have x plus 2 equals 15. Let's write that here. X plus 2 equals 15. The first thing I like to do when solving an equation is I like to separate the left side of the equation from the right side of the equation. To do that, I find where my equal sign is, and then I drop a bar right along the left side of it, all the way down. And then I also draw another line right on the other side of the equal sign. Now this will separate my equation into 2 sides, the left side and the right side. And really that just means literally the left side of the equal sign, which is over here, and the right side of the equal sign. Our variable is on the left side of the equal sign. We can actually box the left side. So let's do that. So if we box the left side, we've got x plus 2. And we have that first term x. Our goal is to get x by itself. So we have this positive 2 next to it, or this plus 2. So we want to get x by itself. So we really want to get rid of this plus 2. In fact, let me zoom into the equation for now. All right. So my goal is to get this variable x by itself. So what I want to do is I want to cancel out this plus 2 with the inverse operation. Remember, we spoke about inverse operations. Since we're adding 2 to this side, the only way to get that by itself is to use the inverse operation of addition, which is subtraction. So we're going to take that equation, and instead of adding 2, we're going to subtract 2. So we're going to put minus 2 over here. That is a line, not what I want. We're going to put minus 2 over here. And then we'll put minus 2 over here. Now the reason why we do that is because when you have an equation, remember that it's equal, right? So in order for it to maintain that equality, whatever happens to the left side has to also happen to the right side. Think of it as like a balance scale. Okay, you have this balance scale and you have this little thing in the middle, and you want to make sure that this thing is balanced. You don't want it tipping to one side and this side is tipping up, or this side tipping down and this side tipping up, and that'll happen if you only do it to one side. But if we have the minus 2 on the left side of the equal sign and on the right side, then that's what you call a balanced equation. Now what will happen is I have this plus 2. I'm going to cancel this out because 2 minus 2 is 0, which is exactly what we want. We can now take this variable x, we can bring it down. So we'll say x equals the result of 15 minus 2, which is 13. And this right here is our solution. Let's zoom back out. So we would say x equals 13, and let's put a box around that. So again, x equals 13. That is our solution. And what that's saying is, hey, the only way this original equation will be true is if this variable x is equal to 13. Now, when we do our check, we're going to start it the same exact way that we had the equation. So we have to have our check, and we're going to start our check the same exact way. We'll start with x plus 2 equals 15. X plus 2 equals 15. Now with a check, all you have to do is make sure the left side of the equation equals the right side of the equation. But we can drop bars again. And our goal is this time to see if the left side equals the right side after we plug in this solution that we found. The next line, we said x equals 13. So wherever we see x, we're going to put this 13 instead. Okay? So our next line is going to be 13. And I'll bring down the rest, plus 2 equals 15. And then we have 13 plus 2, that equals 15. This equals 15. The left side of the equation equals the right side of the equation. Therefore, this is absolutely correct. So here's an example of a one-step equation using addition. Now let's go into an example with subtraction. So for this example, let's say we have 30 equals y minus 7. Okay, so 30 equals y minus 7. In the last equation, we had the variable on the left side of the equal sign. This time we have it on the right side. It doesn't really make a difference. The process is still going to be the same. We're still going to isolate the variable by using inverse or opposite operations to find the solution. So we got 30 equals y minus 7. The first thing I did last time was I put bars around the equal sign to separate my left and right side. I'm going to do the same exact thing again. So I'll find my equal sign, I'll drop a bar down the left side, I'll drop a bar down the right side, and now I clearly have a left side and a right side separated. Now on this side I have y minus 7, so I'm just going to put a box around that. I've got y minus 7, and then I like to just be very, very clear with what's happening in the terms. So I like to drop a line after the y. This isolates the variable y by itself. And what's happening to y? Well, we're subtracting 7 from it. Since we're subtracting 7 from y, we have to think about the inverse operation of subtraction, which is addition. So instead of subtracting 7, what I'll do is I will add 7 to both sides. So I'll put plus 7 down here. That is a line again, my mistake. I'll put plus 7 down here. And I'll put plus 7 over here as well. Then I'm going to make sure I draw a line straight across to show that this is a balanced equation. And I know it's balanced because if I have my little scale here, my little scale line, and my little base of the scale, I don't want it tipping to one side or tipping onto the other side. So I know the plus 7 is on the left side of the equal sign, on the right side of the equal sign. So this is balanced out. And now that my equation is balanced, I'm going to cancel out my 7's because 7 minus 7, or even negative 7 plus 7, that will just give me 0. So I can cross that off. That cancels out. And I can now bring down the y so that it's by itself. I can also bring down my equal sign. And then I've got 30 plus 7, which is simply 37. So we've got 37 equals y, and though it might not look like it, this is a solution because even though it's in reverse, I still have a variable equals a value. I could also just reverse it and it would mean the same exact thing. So if I had, y equals 37, this would be the same exact thing. Either one would be acceptable. Now, the last thing we have to do is a check. And all I'll do for the check is I'll start with the same exact equation. 30 equals y minus 7. So we have 30 equals y minus 7. I'll separate the left side and the right side by drawing a line down the left side of the equal sign and down the right side of the equal sign. And my next step for a check is to plug in what I found for y, my solution. Okay, so we said y is 37. So wherever I see y, instead of writing y, I'll put 37 instead. So I'll bring down, instead of y, it'll be 37. So I've got 37. I'll bring down my minus 7 because I haven't used it yet. I can bring down my equal sign, and I'll bring down 30. So now I have 30, I'll just bring that down one more time. So I've got 30, I'll bring down my equal sign, and then I evaluate this. 37 minus 7, that gives me 30. My left side equals my right side, which means my solution is correct, and I'm finally done. Thanks for watching our video on the math review. If you have any questions or comments, leave them down below. We might use your question in our next video. And if you found this lesson helpful, please make sure you like and subscribe to our channel. And it would really help if you share this and our other videos to any of your social media platforms. See you next time on the Math Review.